Hey guys, let's do our next lesson, which is organic reactions. Sorry, just chalk all over my knees from our last lesson. So we're going to look at our organic reactions. We're going to go through a couple examples of them. And yeah, we'll go through there. So let's look at our first organic reaction, which is a hydrocarbon combustion. So I'm not going to go over that one, as you guys should be pretty familiar with that. That's when we take our hydrocarbon with oxygen, and we always get carbon dioxide and water as a vapor. So again, you guys should be pretty familiar with those ones. Let's go to alkane reactions. Okay, so let's start ourselves off. So an alkane reaction is generally a substitution reaction. So this is when you take a saturated hydrocarbon. So saturated is, alkanes are always saturated. And we basically substitute something in there. So a single hydrogen is replaced with a halogen. So remember, something from group 17 is going to be our halogens. So let's look at methane. So we have one carbon and 4 hydrogens. So this is our methane. And we're going to add it to 1 chlorine. Now I'm just going to use different colors so you can see where it reacts. So let's get our chlorines. Okay. So what do we get? What we end up getting is our hydrogen and our chlorine are going to come together, and then again this chlorine is going to satisfy that extra bond that's now wanting to be bound to something. So we're going to get, let's make sure I have the right color, so our regular hydrogens, and then this chlorine ends up coming in here, and we're going to get chloromethane. Okay, so chloromethane. And then our leftover HCl. Hopefully you guys can see the different colors in there because it really helps explain where things are coming from. Okay, so the same thing with your bromines, your fluorines, your iodides, any of your halogens are going in there. Now, let's say we have an excess of chlorine. Okay, so this is our first reaction, all right? Now, if we had another chlorine coming in here, okay? So we have another chlorine. What's going to happen is it's going to now find another hydrogen, and it's going to do the exact same substitution. So what we're going to get now is a chlorine here and another hydrochloric acid. So we're now going to have dichloromethane and 2 hydrogen chlorides. Same thing, let's say we had another chlorine added, okay? So again, we're going to get an extra hydrochloric acid and another substitution of our hydrogen. So now we would get trichloromethane. And again, we could do one more to make it a tetrachloromethane if we want. Okay. All right. So those are our alkane reactions. All right. Let's move along to our next example, which is cracking. So with cracking, really all that we're looking at is a breaking of our single bonds in our hydrocarbons, and we essentially are just ending up with a smaller carbon chain. So I just need one more connector here. All right, perfect. So right now I am building butane. Okay, so 4 carbons. So what you need to know about cracking is that it always has to balance out. Now, if I had butane, I could break it into 2 different things. I could break it into 2 ethanes, so 1, 2, 1, 2, or I could break it into a methane and a propane. And again, you don't need to worry about which one it is. You'll always either get the products or the reactants, and you just have to figure out what's going on. You just have to figure out, vice versa. All you have to make sure is your carbons are balanced. Now, let's say I break it off here so that I have propane and methane. Well, here's the problem. I don't actually have propane and methane yet because I now have these bonds that don't have anything attached to them. So what do I have to add in order for this to be true? Well, I actually had to split this bond with 2 hydrogens coming in. Okay, so I'm going to have to add a hydrogen here and a hydrogen here to make it actually a true propane and a true methane. So that is what cracking is. Okay, so basically you're adding hydrogen across a alkane and just breaking it into smaller pieces. Now reforming is the exact opposite. So you're going to have your 2 separate different carbon chains. You're going to remove the hydrogen, squeeze them together, and then you're going to get a bigger carbon chain plus your hydrogens left over. Okay, let's go down to our alkene reactions. So a reaction across a double bond. All right, so we have carbon, double bond to carbon. So let's go with ethene. Okay, so we have our hydrogens. And let's add hydrogen. Okay, so what's the only thing that can happen? Well, the hydrogen is going to come here, and what it's going to do is it's going to break this bond. So this bond kind of goes over here, this our little half bond, and this little half bond would come over here. And then again, each of these would come with a little half bond, which is really just an electron. So this hydrogen would go here, and this hydrogen would go here. So what we would end up was when we take ethene plus hydrogen, we would just get ethane, okay? All right, so, sorry, it's just harder to draw with chalk. Okay, and then 1 hydrogen would be here, 1 hydrogen would be here, from this hydrogen, sorry, and then these would just be all of our blue hydrogens. All right, so that's what happens when you add hydrogen. Now, let's see what would happen when we add a hydrochloric acid, okay? So ethene plus hydrochloric acid, again, very same process. One of the hydrogens is going to come over here, one of the chlorines is going to come over here. Okay, and again, in terms of high school chemistry, it doesn't matter where it goes. In this case, because of the fact that there's only 2 carbons. So let's actually change this to propene, because that's actually the example that you guys have. Okay, so here's what happens. The hydrogen could go here, and the chlorine could go here, or it could go vice versa. So these are now where you start to get into your stereoisomers, which means that you're actually going to get a combination of the 2 of them. So here's what you're going to get. You can get CH3. So if the hydrogen comes onto this carbon, we're going to get 1, 2. So our original, oh, I put 1 too many there. There we go. So our original hydrogen plus this hydrogen. So I'm going to put a 2 there in that color to show you where it came from. And then I'm going to have my 2 hydrogens that it normally did, but I'm also going to have my chlorine added here. So this would be called 1-chloroethane. Now, what happens if the chlorine went here and the hydrogen went here? So what we would get in that situation, okay, would look like this. So our hydrogen would go here, our chlorine would go here. So you're going to get, in this case, 2 chloroethane. So what you're going to learn is that you can actually get a combination of the two of these as your products. So you're going to get some 1 chloroethanes and some 2 chloroethanes. Okay? All right. So those are the basic examples of our alkenes. Okay. So moving on. Now, really good question was asked about this one. And basically, first of all, it was named wrong. So you should be starting with pent 1,4-diene. So 1, 2, 3, 4, double bond into a carbon. Okay, so let's just fill lines in for our hydrogens. 1, 2, 3, so there'd be a 4 and 1, 2, so just 2 on that one. Okay, now what's going to happen is we're going to add it to bromine. Okay, so this is where the notes get a little funky because there's a 1 bromine, a 2 bromine, and then a 3 bromine after. So that's why it's a little confusing on this. And there actually is an error on the answer key. Yes, there is an error. I have it on mine, but I forgot to put it on your guys' version. Okay, so basically what's going to happen, oh, sorry, we have another double bond here. So we have 2 carbons, or 2 hydrogens. Okay, so our first bromine, again, is just going to react across one of the double bonds. Now, it really doesn't matter because this is a 1 if you start on this side, and this is a 1 if you start on that side, so it doesn't matter. So we're just going to put it here, okay? So this bromine is going to come here. This bromine is going to come here. So your first compound that you get is so 1, 2, 3, 4, 5. Okay, and then you're going to get the 1 bromine added here and the 1 bromine added here. So your very first one that you're going to get is 1, 2 di-bromo 2, 3, 4, 5 pent 4-ene. Okay, we had a diene, now we only have a ene because it's only 1 single bond. Okay, yeah, 1 double bond, sorry, there. Now what happens is when we add another bromine, okay? All right, 1's going to come here, 1's going to come here. So we're going to get our 5 carbon chain, 1, 2, 3, 4, 5. We have a bromine here, and a bromine here, and a bromine here, and a bromine here. And of course our hydrogens are filled in. So this one would be called 1, 2, 4, 5, and this would be tetra pentane. So here's where we now go back to the beginning of our lesson. Now we have an alkane, okay? So what's going to happen when we add another bromine? So this is where the fully finished answer is not on your guys' key, okay? So we're going to add 1 more bromine. Now remember, we have a bunch of H's all around here that are able to react, okay? So in terms of chemistry 30, you're not required to determine exactly where it would be. You would be always given that information in some form or another. You'd be given the name or something like that. So in this case, what they have as an example is that this hydrogen reacts. So the example that's in your guys' notes with 3 bromines has this hydrogen and this bromine reacting. So then what you end up with is this structure. So 1, 2, 3, 4, 5. You have a bromine here, a bromine here, a bromine here, and a bromine here, which you already had. But now we have one extra bromine here, and then you get hydrobromic acid as well, because that's what's left with this. So that's where you get 1, 1, 2, 4, 5 penta bromo pentane. Okay, and I just realized I forgot my tetra bromo here. Sorry. Okay, so tetra bromo pentane. So hopefully that answers the questions that you guys had on that. Yeah, like I just didn't fill it out that version for you guys on your guys' notes. Okay. So I think the other ones are pretty self-explanatory. When you add water, again, you're just treating it as a cation. So the one hydrogen reacts, and then whatever it reacts with, the other goes with the hydroxyl, and so on and so forth. So what you guys are going to notice is that in the steps that you have in your notes are basically when you add 1 bromine, 2 bromines, 3 bromines. So that's why you have all those different steps for you. With cyclose, one of 2 things can happen. If you're adding if you're adding bromine, you're just going to take one of the hydrogens away from the cyclose, and then it forms your substitution kind of reaction. And then what happens is if you only add hydrogen, what it's going to do is it's going to be very similar to your cracking. You're going to break that double bond, or your bond, and you're going to get your single carbon chain. Okay. All right. So I have a meeting, so I will have to finish this later.